Good afternoon, ladies and gentlemen, and welcome to Engineers Ireland. Just a couple of housekeeping issues before we start. We do have two exits to the arena in the event of an emergency, so there's one just located down to my left-hand side, and obviously there's the one that you came in by. My name is Oliver Dalton. I'm the chair of the Roads and Transport Society, and you're very welcome this evening. We do have a number of online viewers. It's become very, very popular, and we're streaming it live. So if you have any questions after the lecture, just if you can wait till the microphone gets around to you. So as the Roads and Transportation Society, we're delighted to host Stephen Cummins and Andrew O'Connell from ACOM and ROD respectively, who are going to deliver a presentation on the Nelson Street Cycleway and the Canada Street Bridge project in Auckland, New Zealand. This project transformed a redundant motorway off-ramp in the busiest section of New Zealand's highway network. It had over 100,000 vehicles per direction into a colourful and interactive 1 kilometre cycleway. The off-ramp was transformed using magenta surfacing, plexiglass screening. It had 290 interactive LED columns, distinctive Maori artwork, together with a 160 metre long complex triangular shaped curved steel bridge. I suppose this project represents or demonstrates how existing infrastructure can be reinvented to provide a best fit purpose and attractive public transport link. So tonight's speakers, just a little bit of background on the two gentlemen. Our first speaker, Stephen Cummins, is a principal engineer at ACOM. He's a chartered engineer with 10 years experience in the project management and the design of transportation projects in Ireland, in the UK and in New Zealand. This includes an involvement in PPP, design and build, employer design and remeasurable contracts. He has extensive experience in a range of transportation projects from the design phase through to procurement, construction and into the maintenance stage. Our second speaker, Andrew O'Connell from ROD, is a chartered engineer, again, with 10 years of experience in industry, both in civil and structural engineering, has worked in Poland, the UK and in New Zealand. Andrew spent 3.5 years working in Ireland undertaking flood studies and a range of other civil engineering works. He also spent a year in Poland involved in buildings, a year and a half in the UK and 3 years in New Zealand involved in bridge design. He's a graduate from UCD and in civil engineering and has a MSc with a distinction in structural engineering from the University of Surrey. So that concludes the introduction, so I'd like to invite Stephen to give the presentation.
Thank you. Hi, my name is Stephen Cummins. I'm a principal engineer with ACOM. I previously worked with GHD in New Zealand as GHD project manager and engineers representative on this project. I was involved in this project from the end of the detailed design phase through the tender and into construction. Andrew here with me is from Rowan and O'Donovan. He is a design engineer and he previously worked with Novare in New Zealand on this project, and he was a design engineer responsible for the Canada Street Bridge. So there's two key components to this project. One is the Canada Street Bridge and the other is the Nelson Street off-ramp. So the Nelson Street off-ramp is an existing off-ramp, and the Canada Street Bridge connects this old off-ramp and brings the cyclists across the motorway and connects them to Canada Street. So when this project opened, it was renamed the Lightpath, or Tiara E50 in Maori. And so we're just going to start off by showing you a video, hopefully. Showing you a video first off of what the end product looked like. And while you're watching this video, I'd just like you to remember two things. Wherever you see the sandy colour, that's the Canada Street Bridge that crosses the motorway, State Highway 1. And wherever you see the pink, that's the transformed off-ramp. So now you see what the project looked like in the end. So what we want to do now is bring you back to what it looked like 14 months before that when the design started. So the purpose of our presentation today is to take you right back to the start, to where we really started from, which is a far cry from what you see there, and to show you the challenges that we faced, how we adapted to those challenges, and really show you how the project evolved over the course of the 14 months. What we'd like you to remember during our presentation, and what we think was critical to the success and really was a catalyst to the final outcome, was the team's positive and proactive approach to the challenges that we faced, and also the design team's desire to achieve the most for this project and for this space and for this part of Auckland. We knew that this was in the centre of Auckland, and with over 100,000 vehicles per day passing the site, that this could be a really important project, so we always strive to go above and beyond in each component of our design. So the presentation structure, I'll take you through some of the background, and then we're going to get into the challenges of the two key components, Canada Street Bridge and the off-ramp. And so we're going to get straight into it and setting the scene. So here you have is the core team. On your left is Novare, who are a structural engineering consultancy and specialist bridge designers. And this is who Andrew worked for, and they were responsible for the Canada Street Bridge design. In the middle you have GHD, an engineering consultancy who I worked for. They were responsible for design of the other aspects, which included the off-ramp, the intersection and tie-ins, as well as coordinating the design commission, and then during construction, administering the construction contract. Above that is the New Zealand Transport Agency, the client organisation, and then to the right you've got Hawkins, who are the preferred contractor, and below that is Monk Mackenzie, the architects. And just now, when we're talking about the core team, me and Andy would just like to mention two critical engineers, or two phenomenal engineers that we worked with at the time. It was Ganson Govender, who was the engineer's rep, and Duncan Peters, who was the project director at Novare. So it's important that we mention them because they were a big part of the success of the project. So then around that you've got the wider team. You have Auckland Transport, the transport agency in Auckland. You've got Auckland Council, and then below that we've got Land Lab, who are urban designers, and Ion Lighting Architects. So they got involved mid-construction. And then below that you've got Bike Auckland, who are a cycling support group in Auckland and big supporters of this project. So here's a location plan, and I appreciate this won't mean much to you if you haven't been in Auckland, but just bear with me, it'll make more sense on the next slide. So if you look at the top of the slide, that's Auckland Harbour, and then you see the large circle, that's Auckland City Centre. Where the star is, that is the Sky Tower, and then you see outlined is our scheme. So you can see that the scheme is right in or close to the city centre. We're about 5 minutes walk from the Sky Tower and about 10 minutes walk to the waterfront. And these lines are various existing and proposed schemes. So our scheme connects onto that black scheme coming in on the left of your screen, performing a horseshoe shape around Auckland City Centre, and that's Grafton Gully. We connect into Grafton Gully, cyclists go through our scheme, and then they connect onto an on-road cycle lane called Nelson Street on-road cycle facility, and that connects you down to the waterfront. And this is what it really looks like. So this is the central motorway junction, or Spaghetti Junction as it's affectionately known. It's the busiest piece of motorway in Auckland, and what it has coming in from the left of your screen is State Highway 1, which goes out on the top right of your screen, and then coming in from the bottom of your screen is State Highway 16, and it goes out on the left of your screen. So State Highway 1 is the main state highway that runs from the south tip of the South Island all the way to the north tip of the North Island, and then State Highway 16 is known as the Northwestern Motorway, and you've got a series of on and off ramps and links happening here, as well as link roads going across the motorway. And our off-ramp was located just right in the middle of all of that. So we were running next to State Highway 1, running above State Highway 1 southbound and running adjacent to State Highway 1 northbound, and slightly above it at stages. And so our scheme starts on your left at the top of Canada Street, and this is where it connects to Grafton Gully, and you can connections to the Northwestern Cycleway. Then we bring the cyclists down Canada Street, and we have to make a decision then what part from here or from South Street do we make the crossing over to the off-ramp. So this was the easy job that Andy had, to make this massive crossing, and then we continue up the off-ramp and you get to the intersection, and we cross the intersection to get onto the on-road cycle facility. Now at this intersection we have State Highway 1 off-ramp, Stay Highway 16 off-ramp, and Stay Highway 1 on-ramp. So that was quite a difficult intersection to cross, and also it was our only point of access to the on or the off-ramp. And so what you have from end to end is a 1 kilometre cycle facility. And so getting into the project drivers, and here's a kind of a key plan showing you the scheme. So again, our driver was really to make that link from point A to point B. Point A starting on your left, coming down that blue strip, that's Canada Street, that's a side street. Then on the red is the Canada Street Bridge, so the bridge runs alongside the motorway before crossing perpendicular over the motorway. And then in the purple and orange, that is the off-ramp, and I'll explain those colours later. And so you cycle up the off-ramp with your 3-metre screens either side of you, and then you get to the intersection at B, and then you can see there all the on and off-ramps. But one of the major drivers for this project was program. The Minister had given a commitment to deliver this by summer 2015, which gave us 14 months to deliver this project. So how fast was that? So 14 months meant we had 1 month to do the options assessment, and this was to pick where the crossing for the bridge was going to be. Was it going to cross to South Street, or was it going to cross to Canada Street? We had a month and a half to complete the design. Then we had 3 months to carry out the tender, and we had 8.5 months for construction, and that all finishes up in December, which is the first month of summer in New Zealand. So you can see, looking at the video now and looking to the challenges that we face, we have different challenges of what you probably would expect having seen the end product. Our challenges was to deliver this project by summer 2015, to construct a 1 kilometre cycleway from options and design tender to construction. We had to fit major infrastructure. So if you look at that top picture, that's the crossing for the Canada Street Bridge. So we're crossing from this point all the way over onto that hillside in the distance, and then down along that hillside. We had to try to fit new infrastructure, such as the screens, onto a disused existing off-ramp. And you can see in the picture, and the bottom picture there, you can see that the guardrail is all out of shape, and that's what we're going to be connecting to. And in particular, the surfacing is all out of shape also and needs replacement. And finally, we have to obtain all our building consents, resource consents, and all our approvals within that 14 months. So you can see now that notable exclusions from our original scope. So the magenta surfacing or the pink surfacing was not part of our original scope. The 295 interactive LED lights weren't even a twinkle in the Transport Agency's eye at this stage. And just to note that the Canada Street Bridge really surpassed all expectations by getting shortlisted at the World Architecture Awards 2 years running. So think back, bring it back to more modest beginnings in terms of budget as well, and I'll bring it back to this image again. And the reason is that the colours on this image represent treatments of the surfacing. So again, if you start on the left of your screen, the blue represents a concrete for the concrete footpath. The red represents bauxite chip that we're going to use on the steel Canada Street Bridge. And then the purple and the orange is not a surface colouring. The purple is where we're going to mill and replace the surfacing on the off-ramp, and the orange is where we're going to water blast or water cut. So you've seen from the last picture that off-ramp was in pretty bad condition, and ideally we could do with milling and replacing the whole off-ramp, but there wasn't sufficient budget to do that. We had to keep our budget for that quite a large Canada Street Bridge crossing, and also to fit screens onto the off-ramp. So we had to fit the off-ramp is 600 metres long, so we had to fit 600 metres times 2, so 1.2 kilometres of steel screens onto the off-ramp. So that's where our budget was. So getting back to the purpose of our talk, I hope I've shown you that where we started from, and our challenges at the start of the project. We're really focusing on how can we deliver this project by summer 2015 with a major piece of infrastructure like Canada Street Bridge, and trying to fit new infrastructure to an old off-ramp. And now let's go through some of the challenges that we faced and show you how we adapted to that, and really how the project evolved. And hopefully we can show you how, I suppose, the design team influenced how the project evolved. And this is where we're going to get into the two stories of the two parts of the project. So Andrew's going to talk to you about the Canada Street Bridge, and he's going to take you through the design and the construction challenges. And then I'm going to take you through the story of the off-ramp and take you through the screen redesign and the urban design enhancements. So I'll pass you over to Andrew now.
Right, so how you doing? My name's Andrew O'Connell, and I'm a design engineer with Rowan O'Donovan, but as Stephen was saying, I was a design engineer with Novara Design during my time in New Zealand. Now, at this stage, I'd like to say a big thank you to Duncan Peters. He was the project director, the foremost bridge engineer in New Zealand, and a fantastic mentor to me throughout this project. So as you can see here on this slide, this is an image taken from Google Earth to give you an idea of the complexity. So you can see the off-ramp on the left of the screen, and you can see where we're crossing State Highway 1. And the problem was really to get from one side to the other with as little disruption as possible in the space of 14 months. So here's an image taken from site. As you can see, it isn't really actually much of a site. On one side of State Highway 1, you have what is essentially just an embankment squeezed between the 3 lanes of the motorway and the adjacent buildings. And on the other side, the site is essentially just the central median. So as the guys were saying, approximately 100,000 vehicles per day pass through this. So even accessing the central median was quite a challenge. You had to go through Auckland city centre, cross 4 lanes of traffic, and slam on the brakes as you came into sight. I suppose in getting onto the off-ramp, we got lucky in a sense that, well, what we were trying to achieve was landing overhead the pier that you can see there on the existing diaphragm. So therefore to induce as little as possible into the existing bridge. But lucky enough, through the course of the project, we got our hands on the existing drawings and found that the existing bridge was actually longitudinally and transversely post-tensioned. So that gave us the added security, an extra bit on top of that. So moving on, so as it obviously was a cycle bridge, it had to comply with the minimum radius requirements for a cycle bridge. Coupled with that, then the bridge obviously had to fit between State Highway 1 and the adjacent buildings on site, but also curve nicely so the cyclists didn't have too hard of a bend as they landed down on top of the existing off-ramp. Due to the prominence and the location of the site, the construction of the bridge was considered from the off as well, so really the methodology behind the bridge had to take into account its location. So therefore de-risking the amount, de-risking any delays during the construction, such as during the bridge's installation, and also to the construction team due to its location. So and all that had to be done in the space of 14 months, what went from a couple of sketches on a sheet of paper to being walked on. So really from the outset, concrete wasn't considered from the bridge due to its weight. Steel was really the only material considered from the outset, and this was really driven by the 2 factors you see there. Steel can obviously be installed rather quickly by a crane, relatively large spans, and also due to the requirement to land on the existing off-ramp, we had to reduce the weight of of the material that we were using. So at the outset, I suppose the design team, we took the opportunity to really take this on board and really own the project. The area of the city kind of needed a bit of a pick-me-up. So rather than just adopting a really simple solution and jumping over to South Street like Stephen was saying, we decided to try and do something pretty special due to its prominent location in central Auckland. So Dean, who's the project architect, and Duncan came up with the philosophy of trying to find a subtle balance between something simple, sculpture, elegant, but also highlighting the inherent complexity of the engineering due to all the curves as a result. So this here was the only alignments that we found could actually work. So on the left of the screen you can see the off-ramp. That green section there you see is 30 metres of a concrete off-ramp that tapers from the bridge down onto the existing off-ramp. The remainder then of the curves is actually Canada Street Bridge. So you can see it's articulated with a single bearing on top of the existing off-ramp. Pier 1 is located in the central median, and there's a 39-metre span over to Pier 2 on the other side. The remainder of the curves then are really squeezing between the existing buildings and State Highway 1, which is the little line you see at the bottom, and the bridge finishes then at a concrete abutment down at Canada Street. The bridge itself ended up being 160 metres long. The concrete off-ramp was 30 metres long. The bridge had 5 different horizontal curves, all of different radii. It had 2 vertical curves, and the spans you see here, the span that went from Pier 1 to the bearing and from Pier 1 to Pier 2 was haunched. So over Pier 1 the deck was 1.5 metres deep, and it tapered down to 800 mil deep over Pier 2. The remainder of the spans then had a constant depth. So the geometry alone, even to try and make it all fit, was very complex. So keeping that in mind and just reminding yourself of the philosophy of simple, elegant, yet complex, to try and emphasize that whole approach, we came about to using shapes such as triangles, diamonds and rhombic shapes. They are not typically used in bridge engineering because they're quite awkward to work with, but they're simple shapes and they highlight elegance and simplicity, but yet they're inherently complex due to their angular nature. So from the outset, that was the approach that was adopted for the deck to try and keep as close to the philosophy as we could. So looking at the deck now, and bearing in mind that we had to use only steel, and all the curves as well, we were obviously going to go with a closed form section. So the actual inverted triangular shape was derived and used from the outset. And as it had to be all steel, it ended up being a steel orthotropic box girder, as we had to stiffen all the flanges all the way around. So moving down onto the substructure now, Pier 1 was done quite different from Piers 2 to 6. Pier 1 is located in the central median, so therefore you're able to see it as the cars drive. So it was decided to do something pretty special with this as you approached it. And you can see from the images on the right, these are courtesy of Dean McKenzie, he provided these for the presentation. You can see his initial sketch-up of Pier number 1. So what you can see is we were trying to achieve simple, sinuous, unbroken curvature from the superstructure down into the substructure. So there's no obvious point of connection. So there you have it. It's nice and simple, but yet it gives it hints towards a degree of complexity. Piers number 2 to 6, located on the other side of State Highway 1, were Y-shaped. So they cradled the deck overhead as it was landed in. So they were quite different to Pier number 1. So at those locations, the deck simply sat on pairs of elastomeric bearings. And it being Auckland, there is a degree of seismicity, so it had an enhanced degree of lateral restraint. So just moving through a few more details, there's the guys boring the piles underneath Pier number 1. So underneath Pier number 1 is a 1.2 metre diameter reinforced concrete pile, and under the remainder of the piers 900 mm diameter concrete piles. The ramp itself then, as we transitioned from the steel deck down onto the existing off-ramp, started out as a concrete frame, and as we tapered down onto the deck it transitioned using foamcrete, very light, very not particularly dense concrete. As I spoke about, the pot bearing on the off-ramp was a unidirectional pot bearing, and through a number of iterations we found that if we angled that pot bearing parallel to the main span crossing State Highway 1, that gave us the best and the most enhanced transverse stiffness of the bridge. From a durability point of view, the deck itself was hermetically sealed, so therefore once it was tested there's no more getting inside the box. So therefore there was no corrosion protection implied inside the box. During the construction, what we did is we actually introduced 2 burst discs into the bridge. We're concerned that if there was ever a fire underneath the bridge on State Highway 1, due to its very prominent location, we actually installed 2 burst discs on both elements of the span to ensure that we'll never have too much pressure inside the deck, so they will pop at a certain pressure just in case. Now moving on to the corrosion protection, at the outset we had, well you can see it here, the base was zinc metal spray and a 2-component epoxy, but we'd originally specified a black polyurethane to highlight the shape. But in consultation with industry during the construction, we actually changed our mind to polysiloxane. Now polysiloxane is really the Rolls Royce of painting systems. It's quite expensive, but it gives a fantastic finish, and especially what we were after. And it also had another advantage, and this is quite unique to New Zealand, is it has a unique resistance to UV light exposure. So typically paint systems, once they start degrading, they'll keep degrading in a linear fashion. Whereas actually polysiloxane will only degrade by 2 to 3% and taper out. So therefore over the lifespan of the bridge, the bridge will never dull in appearance. So this, the client was particularly happy with this due to its prominent location. They obviously don't want to be painting it every so often. So then moving on to the design standards, bridges of this nature are designed in accordance with the NZTA Bridge Manual. So that is really more of a guidance document, so that points you in the direction of all the relevant codes. So typically in a situation like this, you'd either design it to a relevant New Zealand or Australian standard. Unfortunately, the Steel Bridge Australian standards say in the scope of the first chapter that these codes are not to be used for the design of steel orthotropic box girders. So if you look into the commentary of that, and to give a nice little one-liner saying, if you do actually in fact have to design a steel orthotropic box girder, you have to use BS 5400 Part 3. So that was quite an interesting feature of the design. As you can see there, BD 37 had to be used for the wind load applications, BD 49 for the aerodynamic effects, and the bridge manual actually refers you to the British National Annex of 1991 Part 2 with regard to assessing the pedestrian vibrations. The substructure was actually designed to the New Zealand standards, so it was a real mishmash of everything really. So moving on to the analysis. The analysis was conducted in StadPro and in Midas Civil. We adopted an elastic design as opposed to a ductile design. Now that was done for two reasons. Due to the low level of seismicity in Auckland, there was no real advantage in designing the bridge with a degree of ductility, so therefore we had designed it elastically. And also the fact, and as you would have seen in the previous slide, there was a mix of different codes, so therefore essentially to simplify all that, we adopted an elastic design approach. The itself was conducted, let's say, globally in the 3D frame models, but due to the peculiar geometry of the bridge, we had to use quite a lot of finite element analysis software. So on the top you'll see just a snippet of one of the analysis of the deck, and on the bottom you'll see a screenshot of the analysis that was done on Pier 1. So actually in the FEM model you can actually see the philosophy behind the deck. You can kind of roughly make out where the stiffeners are. Inside in the deck itself then it had a vertical web to deal with the shear, and all the remaining plates all stiffened. And then I suppose in addition, Dean provided a rhinoceros model, and in addition to our drawings for the fabricator, who generated an extremely large three-dimensional solid work for the fabrication of the bridge. So the bridge itself was fabricated in Hamilton, which is about 1.5 hours south of Auckland. And here you can really see the philosophy behind and the way the deck actually works. So the deck is actually built up from an I-beam. So the top and bottom flanges there are actually 25mm plates, and the web itself, the vertical web, is 20mm plate. The remaining steel then is simply just 12mm stiffened plate all the way around. So the idea behind that was the eye girder was essentially almost sufficiently good all by itself to deal with the required loading, and the remaining plates then gave it stiffness and provided the inherent torsional stability. So you can see in the photograph on your right the process behind the fabrication. So the guys essentially made the eye girder in the middle first, attached the bottom flanges, put on the stiffeners, and then put in the full height diaphragms. They were spaced at 3 meters. So as it was a steel orthotropic box girder, this actually led to a problem. We had to find a way to ensure the longitudinal continuity of the top stiffeners. Typically in box girders you get back inside them and you form a connection then, as they're typically quite large. Obviously we couldn't get back inside this. So we actually had to come up with a fabrication sequence to ensure that we could provide the longitudinal continuity. So what we did was, the top flange was actually made in a number of stages for each segment. So the top flange would go on with the first plate, as you can see it there in the photograph on the left, and at the end of each plate you'd have a series of semicircular holes. In the center photograph you'll see the next stage. So simply a plate comes on next and the two edges butt up against each other, so what you're left is a series of holes left in the top flange. Inside that then we had a bolted connection formed, so therefore the top flange was actually on and guys were able to get their hands inside to form a bolted connection, so therefore that ensured the longitudinal continuity. The guys take out their hands, their tools, and put a series of circular discs and weld them into the top of the deck, so therefore we ensured the longitudinal continuity of the top stiffeners and also being able to seal the deck. So here's just an image of the piers now. So you can see Pier 1 is actually quite different to Piers 2 to 6, so you can see the Y shape there before it goes to the paint shop, and you can see Pier number 1. Just to add to the complexity, this was tapering as it went down, the geometry was constantly changing, and its smallest and thinnest point was at the bottom. You can see they are highlighted in green as well. This was done purely for the construction. These are temporary shim plates. As the main span was going to have to be lifted over State Highway 1, there was always a risk of something not fitting. So the fabricator actually welded on these temporary shim plates that actually guided the deck into position to ensure that it could only fit in the right position as we were landing it into position on site. Okay, so here we are just before the lift. So obviously the first lift we did was the heaviest and the longest, and it was going over State Highway 1. So the first lift was 54 metres long, it was 96 tonnes of steel, and at this point the deck is actually already hermetically sealed. If you can make it out just underneath the beam there, you can actually see a bolted connection waiting to sit on top of pier number 1. So at this point the deck is actually already sealed. So therefore, when the guys go to test the remaining on site, they're not actually testing the deck, so it's much easier if you're testing piers as opposed to testing the deck. So that has already been sealed. And also as well, you'll notice in the photograph that there's a series of temporary diaphragms on the face of the beam. This was done so that the beam actually held its shape as it was being lifted into position, and this allowed us as well to form a bolted connection to that point, to the next beam that was going to join onto it. You'll notice this is a 250 tonne crane, and you'll notice there's a 120 tonne super lift in the background, and one of the span number 3 waiting to be lifted into position as well. So this is it, the night of the lift. We only had a 6-hour window, so therefore the beam was pretty much ready to go as we got the all clear to lift it in. As I was saying, there was a 120 tonne super lift, and in total the bridge was lifted in over 2 months with 7 lifts. To make the first lift a bit more complicated as well, there wasn't actually enough room on site for the bridge or for the crane to attach onto the super lift that it required. So what actually had to happen was it actually had to pick up the beam, it had to swing it out over State Highway 1, and then it had to slew about 2 or 3 metres, let's say, towards the screen, swing around, and then it had to attach onto the super lift. So there wasn't actually enough room on site to attach the super lift for the initial lift. And just to make sure, then the vertical cables of the super lift, you can't really see it in this photograph, we're only within 300 millimetres of the off ramp behind, so there was absolutely no room for error on this lift. So there it is, coming into position. So as I said, it was going to be a full moment connection, but actually in the temporary condition it was only a bolted connection. So what this allowed us to do was essentially during the 6-hour window for the crane to lob the beams into position and get them into position and decouple, as opposed to having to weld on site during the very narrow window. So you can see it's only bolted in the transverse direction. The bridge was actually allowed to rotate longitudinally. So what the guys would do is the bridge landed into position, they were able to put in a series of temporary bolts, and then the crane would decouple. So therefore the bridge was in position, the crane was able to decouple, we were able to hand back the road, and then they were able to weld it in their own time to form the moment continuity. So here's the span, as you can see in the top left, landing over and landing onto pier number 1. There's a nice photograph of the beam as it comes out and lands over the off-ramp. That dimension there, it only cleared the bridge by, I think it was 280 mil, so really not much room at all. And you'll notice as well, pier number 1 has this little shard plate over it covering the connection. So the idea behind pier number 1 to give the sinuous curvature was, we obviously had to provide a moment connection, and that was done with the welding you would have seen. So to give the sinuous curvature, that was all subsequently covered with a 3mm shroud plate, and then the pier was tested. So therefore the actual connection is inside the pier, you never see it. But to give the effect of sinuous curvature, that's simply done with a 3mm curving plate. And then the photograph on the bottom is, it shows actually the entire bridge in its final position, and at the locations of where you see the blue covers, that's the guys forming the moment continuity as the bridge is being all welded together as they go down along. So this is it. Now the first image again just shows pier number 1 with the wonderful reflections of the polysiloxane. The bridge is actually lit up with a series of LED lights underneath the handrail. It provides a wonderful reflection of the buff-coloured bauxite chip. It's very interesting at this point. The bridge actually disappears behind the building and actually reappears again, so it's quite interesting when you walk on it. Just to give an idea of how close we were actually at this point, the building you see in that photograph, the bridge was less than 500 mil from the wall of that, and the little building you see in the third photograph over there, the bridge was actually only 240 mil from the wall of that, so we really didn't have much room to spare at all. So you can see as well the elastomeric bearings. Happily enough, they were already by default coloured black, so that was handy. So they were cradling the deck overhead as it was landed into position. So that's it. So that's Canada Street now in her final position, winding her way from Canada Street on the right hand side and landing on the off-ramp on the other side. The bridge on average only weighed 13.1 kilonewtons per metre and came in based on, well, the exchange rate at the moment of about 4,250 euros per square metre. So it was quite successful in the end, even economically for the client, so we're pretty pleased with the outcome. I'll now hand you back to Stephen to take you on down through the rest of the off-ramp.
Thanks, Andy. So now I'm going to tell you about the story of the off-ramp. And as you can see, the story of the off-ramp really all happens during construction. So day one of construction, we take the opportunity to redesign all the screens. So you can see on my right the original guardrail or screen design, and then on my left is the new design being installed on site. So the key difference here was what's in red there on the original design, which was the guardrail. Working with the Auckland Motorway Authority, who are the asset owners on this, the requirement was for us to take off the guardrail and place it in front of the screens. During the tender period, we got the opportunity to discuss this further, and now we were allowed to attach the screens in front of the guardrail to the guardrail. So this gives us loads of opportunities to value engineer these screens with the contractor and to improve their look with the architect. So just focusing on the new design, if you look on my right, that's the completed screens. There's you got your plexiglass at the top and you got your perforated panel at the bottom. And then on the opposite side, you see the plexiglass sitting on the shelf, and that's because the perforated screen hasn't been added there. So that's mid-construction. So the key differences here in this image, what we've taken the opportunity to do is raise the height of the perforated panel, and this is to allow greater maintenance. We've also have the perforated panel and the plexiglass on two separate clamping plates. So you can see on the opposite side of the picture, the benefit of this is that we can leave the heavy material, which is the plexiglass, in place on the shelf and take off the perforated panel for the majority of your routine maintenance. So there's big benefits to this. The other benefit was that obviously the perforated panel is a much cheaper material, so it allowed us to make the overall cost of this cheaper. We got the architect's input in this to make it kind of try and tie it in with the Canada Street Bridge team, and also got his input into small details like the perforated panel. So what we did is we made the perforated panel as open aspect as possible, and the idea behind this is we wanted the cyclists and pedestrians to see the guardrail and to really see the grunt of the infrastructure behind it, so that they knew they were cycling on an off-ramp. But probably the biggest thing for the change was value engineering the connection. So for each of the screen columns, we had to connect it to the guardrail upright, and this was for load transfer. So each of those screen columns had to line up with the guardrail uprights, and we had about 600 connections to make. Now the guardrail uprights were all unevenly spaced and uneven heights, so we had about 600 uneven connections to make. We had guardrails from 1.1 to 2.2 apart. They ranged in height from 490 to 575. The bolt spacings varied in width from 100 to 230, and the guardrail itself varied in width. So this was all non-standard guardrail along the whole length of the off-ramp. So working with the contractor, we just came up with some small clever solutions to try to reduce the variances and allow some tolerance in our design. So if you look at the circle in red, what we've done is we've got an oversized clamping plate, and this allows us to hide a lot of the tolerance for the plexiglass screens and the perforated panels behind it. So we can have the plexiglass quite close together, or we can have it a little bit further apart, and that takes up some of the tolerance. We've also slotted the shelves that the plexiglass sits on to come up with less variations in those shelves. If you're looking at the blue circle, what we've done is we've gone with the smallest connection we could to the guardrail, so vertically the smallest connection. And this was to allow us to connect that to the bottom of the guardrail, the middle, or the top of the guardrail. And that allowed us for some height tolerance, and we could pack also underneath the base plate. Also in green, we've made the connection narrow, but we've made it as wide as possible to allow for all the variations in the bolt widths. And finally, in the base plate, we've allowed for 3 holes in each corner of the base plate to make one connection. So provided we make one connection in each corner, it's structurally sound. And the reason for this is that we wanted to avoid the rebar in the existing deck. So all in all, we went from 600 unevenly spaced guardrail connections, and we managed to standardize it down to about 18 columns and 14 standard panel widths. So this was the first half of the construction phase, redesigning that. And then about 3 months from the end of the construction, Auckland Council and the New Zealand Transport Agency came back to the design team and said, can we do more? And this was really the turning point of the project, and this was really acknowledgement of all the work that the design team had done, really to go above and beyond and try to ensure that the finishes were of top quality. And this goes from everything from the screen redesign to some redesign work we done on Canada Street, and again to the finishes. But the real big turning point was the Canada Street Bridge. And as Andrew was saying there, the bridge really set a precedent and really generated a lot of attention when images of it being constructed in the workshop started to appear. And then Auckland Council, who hadn't been really involved in the project at this stage, came to NZTA and said, look, we'd like to provide some more funding to really enhance this project. And as Andrew's bridge was pretty much the complete project or product already, the only thing we really had to invest in was the tie-ins and the off-ramp. So then what we did is we had a series of workshops with the architect. That's when we got another urban designer involved, and we sat down with the design team and the contractor and figured out what we could do in the last 3 months. And so everybody in the team was up for this challenge. It wasn't that we couldn't design it, or it wasn't that it couldn't be constructed. Our main constraint was what we had on site already. So we've already started installing the screens, and there's already material on its way from Germany. So those were our constraints. So looking over on the left, my left, this is some of the images from that workshop. You've got the bold colour, which is just the inspiration for the pink surfacing, so that we wanted something bold. In the center of your screen, we've got the concept that we're going to make one side of the off-ramp dedicated to the city and a lighting side, and the other side of the off-ramp with no lights and dedicated to the view of the harbour, because you've got really good views of the harbour. And then the vertical lines here is just the inspiration for the 295 interactive LED columns. So then we had to go about designing this and constructing this in the last 3 months of the project. And this is just some of the complexities with this. First of all, we had to move all the lighting columns from one side of the off-ramp, the western side, all onto the eastern side. And then with the ducting, and then with that we installed, if you see in the green circle, we installed sensor cameras on each of those lighting columns. So now we've got a lighting column every 20 meters on the eastern side with a sensor camera. Then coming down to the photograph, you see the LED units, and this is the LED unit. It comes in 2 parts. Now that we've the screens already on site, we couldn't find a unit off the shelf, or a unit suitable off the shelf that we could use, so we had to design these units bespoke. So the way we designed them was we designed them in 2 parts. You can see the front plate, which is like a plexiglass with a diffuser, and then in the back plate there you can see you've got the 2 LED strips, and then down on the bottom it's all, you got your DMX controller, your driver, and all your equipment. And so the idea behind this was that you could remove the front plate for the majority of the routine maintenance, and then put it back on. And then just talking about the engineering and the urban design, and I've just highlighted the ducting for an example. Even down to the ducting, we went down to that level of detail to design it. In the blue was the original ducting design. Like I said before, the perforated panels were open aspects, so people could see the infrastructure behind it. So we designed this to be recessive. But now we're after introducing 295 LED columns, and we have to have about 1.5 kilometers of power cables and data cables, which can't be run next to each other. So we had to design the trunking in red then as well. So what we did is we designed some trunking that is raised on shelves, and again we designed it to be recessive in the background. So this is kind of the level of detail that we had to go down to. And here's what it looks like. So starting at the bottom of your screen, you see the resin surfacing, which is an epoxy resin with a recycled glass bead. Then coming up to my right, you've got the posts and perforated panels, and they're from Callum's in Whangarei, which is about an hour outside of Auckland. And then we've got the plexiglass above that from Germany, and it's got graffiti guard on it from Israel. And this side is your harbour view side, so it's got no lighting and it's purely for a view of the harbour. Then when you come across to the city side, you've got our luminaires that we've got from Italy and our lighting controllers from the USA. So the lighting controllers are important. This is an added feature we brought in. The idea behind this is in a situation like a festival or where we get approval, we can dim the overhead lighting and make a bigger effect of the amenity lighting that we have below it. Then coming down from that, I've noted CCTV, but you can't really see it here, but we've got about 7 cameras in total on the site here and about 4 on the bridge. And then you've got on each of those columns you see the little bulb, which is a sensor, and then we've got our bespoke LED units and trunking, so they're every 2 meters along the length of the off-ramp. So just giving you some more images of what it looks like. You can see this is the harbour view side, you can see the harbour bridge in the distance, and now you can see how the perforated panel is quite open, and to really give you a feel of what it's like cycling on the off-ramp. And here we are in the night, in the mix. When you're cycling past, it's a really cool experience because there's just the vertical lines every 2 meters, and with the sensors, the lighting just interacts and moves with you. And here's an image just to show its capabilities, and I'll just talk through this for a little bit. So you can see we've used RGBW, which means that the colours we can produce is really any colour we like, and here we are matching the Sky Tower. And how the system works is we've got a PC in a cabinet set up on site, which is connected to fibre, and is controlled by the lighting architect on his phone. And what he has is a series of programs. So at night the lighting comes on and is on until 4 o'clock in the morning. It runs in a series of programs depending on what program it is that night. The program could be that all the lighting tonight will be red or will be multicoloured. And the lighting just moves and changes in a slow pace all night, and that is until someone interacts with it. And so each of the columns has got a sensor, and the sensor is capable of picking you up. So again, depending on the program, as you're cycling past or walking past, the lights will either light up, change colour, or interact with you. So it's a pretty cool experience as we cycle on at night. And I just added this quote here from Barbara Cooper from Bike Autumn because I really like it. She says, "I knew this was going to be memorable, but I didn't know that it was going to have soul, that it was going to have mana, and that it was going to have spirit." So mana is the Maori term for a supernatural force in a person, place, or object. And this is because the involvement of the artist Katz from the Maori Arts and Crafts School. So in his involvement, some of the features we've added is the kuru at the start of the cycleway, at the start of the off-ramp. Then we've got a marker pole, which is a 6 metre high post with Maori carvings in the top of it that's lit up at the start of the off-ramp as well. And then on the harbour view side, we've got these art panels. It's not a very good picture, but what they are is we've got carvings in the steel. We've got 15 of those panels that are spaced along the harbour view side. And this is what it's all about. So what we were trying to do is we were trying to create a space that was fun and safe for people to use. So like people are bringing their kids to learn how to cycle in the centre of Motorway Junction with over 100,000 vehicles per day. We've got couples going there to get their wedding photographs and engagement photographs taken. Auckland and New Zealand are also using it as a symbol. So here they're using it to show their support to Orlando following the atrocities. It's been used extensively in advertising, again for modelling, but quite a lot in TV and TV adverts. We've had over 100,000 cyclists use it in the first 4 months. Now this is a big milestone. This is just cyclists, it's not counting the pedestrians. This is important because this was a route that previously didn't exist through the central Motorway Junction. So 100,000 cyclists have chosen to use this new route through the CMJ. It's recently been in the New Zealand Herald for saying how much it has benefited cycling in Auckland in particular and how it has increased the cycle numbers. And finally, Malachi Fikatora, the New Zealand or All Black centre, just signing off to his Twitter followers on his way to Chicago to get beaten by the Irish rugby team. So I hope, back to the person I talk, so I hope I showed you where we started, and I showed you that where we started and where we end is completely different, and really all the challenges that we faced and how we adapted and how the project evolved. And I hope I've showed you, and Andrew showed you, how really the design team's efforts has helped the evolution of the project. And now just to go through some of the awards that we were fortunate to win since the project opened in December. We won Public Works Australasia Best Project over 5 million, winner of the New Zealand Planning Institute Rodney Davis Award, winner of the New Zealand Institute of Architects Planning and Urban Design Auckland Awards. We were shortlisted at the World Architecture Awards for Future Infrastructure Projects. We were winner of the Architectus A+ 2016 Highways and Bridge Award in New York, Silver Innovation Award at the Association of Consulting Engineers New Zealand. And then the Transport Agency gives each of their consultants a PACE score, which is a performance score, when they finished one of their commissions, and both Novara and GHD achieved superlative, which is the highest score you can achieve, and I don't really know anybody else who's achieved this score, and certainly this is the highest score our organisations have achieved. So also on the horizon on Friday, we're in for the final of the New Zealand Institute of Architects National Award. So we've won the Auckland Award, so now we're into the National Award on Friday, so fingers crossed. And next week we're shortlisted at this year's 2016 World Architecture Awards, and this time we're in a different category for Best Transport Project. So hopefully we might have some good news next week. So I hope you enjoyed the presentation, and thanks for your time.
Thanks, gentlemen, and congratulations. I've never seen so many awards. I suppose just a comment for myself, that this is a great example of how multidisciplinary design can provide a piece of infrastructure that is world-class, shall we say. We do have quite a significant number of people online, so my colleague Ali is just going to run around with the microphone, so if anybody has any questions that they'd like to ask the two guys, I'll ask them to come up beside me here so they keep close to the speaker. So, has anybody got any questions? Donald?
Thanks, Oliver. Donald Miller from TII. I actually have 3 questions, but this number 2 and 3 are probably quick and easy answers. But just first of all, maybe I missed it, but was there an overarching national strategy document or a plan or a study that was done that came up with identifying this as something that needed to be done, or was this just something that some ingenuity kind of said, oh, wait a second, we've an off-ramp here and we've a need down there, and why don't we do this? That's why I just wondered what the genesis of it was.
Yeah, I can answer this. Yeah, it's probably, I didn't really cover that well. There was a city centre, a central motorway cycling and walking plan in 2012 that identified this as a potential cycleway. So that was his first mention, and then it wasn't until the minister confirmed that he would like to see it opened that we really knew that it was going to go ahead. So no other work really had been carried out up to then.
Okay. Fair enough, thanks for that. Sorry, the other question was just perhaps obvious, and maybe comes from no roads background, but the idiot factor in terms of, I saw some lovely, I think you call it plexiglass panelling there, which would be like manna to heaven from certain individuals if it was placed above the M50. And I don't know about plexiglass, but does it have the resilience to prevent some hardy bucks having a good go at it, like that? Yeah. You didn't have fragments of glass or material falling down on the A1, I think, was it underneath? Is that it?
State Highway 1. Yeah. No. So we've done a bit of research into it at the start, but the way the scheme, if you can actually look at the screen, and you can see just down at where you can see the sandy colour, which is the bridge there. So what happens is anybody who's using it enters a network there. So when they enter the project, unless they want to get out of the site, they have to travel almost 800 metres to the other end of the site. So what we've done to just prevent people or discourage people is we've used CCTV cameras throughout, and in particular at the board entrances we've got facial cameras there, and we've got cameras throughout. And as for the actual plexiglass itself, what we've done is the product we've used as a higher standard than other ones on the shelf, but what you can do is we've got graffiti guard in it. If you were to try and mark it, you can take the graffiti guard off. Even if you mark the panel itself or try to mark the panel, you can buff up the panel, but there are about 15 millimeters thick, so yeah, you wouldn't be able to use them. They're approved noise barriers as well, so they're approved with the transport agency. So yeah, they're pretty heavy duty, and that's why we don't want to be lifting them off. Yeah.
Sorry, my final question, I promise I'll let go of the microphone now. I noticed it's a common thoroughfare for cyclists and pedestrians, so just how did you manage that whole conflict between pedestrians and cyclists? Did you see any delineation or designation between one and the other?
This is a very common thing in New Zealand. The shared paths are very common in New Zealand. So I've noticed that since coming home that this is we try to separate them, but in New Zealand it's quite common to have them shared. Now on the off ramp, that's why the screens are there. It's very much a shared space because you've got about 6 meters width there, so you've got plenty of width on the off ramp, and there's no real issues with that. The bridge is more of a transition, so because actually you're climbing and you're going around corners, you're kind of transitioning across the bridge, so you're not inclined to stop. As a cyclist, you continue on. So we've had no issues with it so far. Yeah.
Have we any more questions from the audience? Okay.
One comment and one question. I think the comment is that it's a very good example of multidisciplinary work, but it's more so a very good example of the public or the powers that be providing proper funding to do innovative projects. And I hope people watching see it and think that's a great idea. Let's try something like that here. The question I had was actually on the panels that you put up the side of it. They look like substantial wind sails to me, with very small connections at the bottom. So just wondering about those.
Yeah, no, the screens, yeah. Yeah, no, the screens have all been structurally designed, got their PS1s, or their producer statements 1 through to 4, so they've all been structurally designed by a chartered structural engineer. Yeah, there's a connection to the base and also a connection to the guardrail. I suppose you're trying to reduce the connection into the deck as well. That's why we're using the guardrail to connect to also. So they're pretty grunty. I don't think you would. Yeah. I wouldn't worry about the movement yet. Yeah.
Have you less wind in Auckland than here?
No, you'd have a bit more even during the construction of the bridge. You know, both the connection on Pier 1 in that bridge is temporary condition. An actual tropical storm came in and hit it, so I was delighted with the amount of bolts that we put in. I remember went down to the office on the Saturday just to make sure, and there she stands anyway, you know. But yeah, no, it can get pretty windy in Auckland as well.
and in that respect, the screens are quite good like that, because you're quite exposed to the harbour there, and cyclists. And we haven't tried to adjust the guardrail camber. So you know, it's probably slightly out of standard to camber going around there. So if a crosswind came, you could get knocked over, as opposed to the bridge, which is a new design, and it's all within the requirements. So
yeah.
Just a final question for me, perhaps. There's an existing bridge, a very old bridge that goes across Grafton Gully, between the university and the hospital, and that also has I don't know if it's glass or plexi screens along either side, and they get very, very dirty. In terms of safe design, how have you guys built in cleaning both sides of the, I imagine, I know you mentioned routine maintenance, but I can hardly see you taking the panels off to clean them. How do you actually get to the other side to make sure the glass is clean?
So this is something that we were just doing, we kind of discussed with the Auckland Motorway Authority, so we've involved them. We pretty much, Auckland Motorway Authority, who will be the asset owners and managers, we pretty much met them every 2 weeks throughout the whole project and went through the design with them, that they were happy with it. But the screens themselves are open aspect, so it will get dirty on the outside, but it will be more inclined to get dirt on the inside, such as birds landing on them. But the way to clean them will be, they're looking into a way of, like, it's obviously just a mobile scaffolding that would be able to clean them from the inside. That would be the preferred option, reaching over. But the other option would be to, we'll have to let someone go in behind and connect them to the actual post and grad rail, and continually move along on a 2-point connection the whole way along. So, but we haven't really had any need to clean them so far, and it's there a year now almost. Yeah.
But so did it form part of the design process in terms of where you would actually have connections to allow somebody maybe to?
We were hoping to design like when we were doing the asset owner's manual when we were leaving, and the idea was that we were coming up with a scaffolding solution that you would work from the inside.
So is that retrospective? Is that afterwards?
It is slightly retrospective, because the screens are a requirement from the Auckland Motorway Authority, so we needed to put them in for their requirement, and we also needed to keep them safe to prevent people going behind them. But yeah, no, you can connect on, like, they connect to the guardrail and the screens, because fundamentally you're walking on an existing structure as they would have maintained it before. So this is a structure that the AMA was, without the screens, that's how they maintained it before. You walked on the structure, so the screens are just there really to protect the public.
Okay, thank you.
And take one more question from the audience if there is one. Okay. Guys, I have one quick question myself. What was the overall construction cost? And the second part of that question then is, is there any design philosophy behind the magenta colour?
The overall construction cost, the tender was, I think, 8.7 million New Zealand dollars, and then we had 2 million more for the artworks after that. So that was the investment that Auckland Council made during construction towards the end. So that's what it was. And the majority of that went to the screens and to the Canada Street Bridge, like I said before. And the magenta surfacing, that was the colour was picked by the architect and the artist, the Maori artist Katz, and there was a number of factors that came into that. Some of them was they didn't want to pick a colour that was already in the network. From the workshops, they wanted to pick something bold and fun, so that kind of narrowed down the colours straight away. They went out to the public and had a quick survey, and the public said they wanted something modern. And also, so that kind of narrowed down. I think the colours shortlist was getting down to an orange or a pink. And they kind of went with the pink in the end because it also tied in with what Katz was doing, which ties into the Tutora tree. So that's something that Katz felt strongly about. But also because there's the K Road neighbourhood beside it, it's quite a colourful neighbourhood, and the pink really ties in with that. So yeah, and it's been really popular actually. So
very good. Thank you very much for that. Just to finish up the formalities for the evening, just to say thank you to the lads for giving us a wonderful presentation. Also to thank Donal Minock, our Vice Chair, to thank Ali Gleeson, our PRO, and to Deirdre Neff, our Secretary, for all their help in delivering this evening's lecture. Our next presentation will be on the 8th of February, and at this stage we're not 100% sure what that will be on at this stage, but just to say, if you can plug it into your diaries, it is a date that we'll be having our next presentation. And finally then, just to call on our PRO, Ali Gleeson, to give the vote of thanks.
Because we're not fed up of voting today, I suspect. No, look, I just want to say on behalf of the Roads and Transportation Society, and of course the Structures and Construction Society, who are our division, who've also co-hosted this event, that the presentation had a very good mix of videos, pictures, diagrams, and that certainly helps in terms of trying to convey what are very technical issues, but again, you managed to convey those issues in a very clear and constructive way. So well done on that. I suspect there was some rehearsal maybe, but you seem very natural as presenters, and I certainly wish you the very best with future awards. It looks like you're favourites in my book, so well done on that. I wanted to say that it's not unusual in our industry to have a client demanding something, a high quality finish to a very tight budget to a ridiculous program. It's great to see it happens on the other side of the planet as well as here, but it looks like you certainly rose to the challenge, and you motivated your team to achieve that as well, and that's something that probably will go unnoticed, sadly, but it's certainly something that I certainly appreciate, and I think you guys should be applauded for being able to do that. The last point I wanted to make, and this is something that I'm happy that I've enjoyed, and I'd say most engineers have enjoyed, is being able to translate the skills and qualities that you've both got from an education in Ireland as civil engineers, and then to use that as a passport to travel the world and to meet new people, work in different cultures, and to provide that expertise to our peers on the other side of the planet, and then bring that knowledge and experience back to Ireland as well, which I'm delighted to see. Hopefully there's more people like yourselves coming back to Ireland with similar experiences. I'm hoping also that maybe some children in schools will see that engineering is a fantastic passport to the world, and you guys are two very good examples of that. So I would ask everybody just to congratulate you as we normally would. Thanks guys, thanks very much.
Thank you.
Cheers, thank you.